Welcome my dear children. Good morning to all. Okay students, we have already completed now the unit first matter. Now we are going to start today our unit second, physical quantities and measurement. I hope that you have already started to learn the question answers which I have given from first chapter or first unit. Okay, at least 5 each questions you have to learn one day. Okay, don't keep the question answers as mountain. Okay, so now we are going to start our second unit, physical quantities and measurement. All of you take out your book and others please stay on video and watch the video carefully. Okay students, this is our second unit, physical quantities and measurement. From this chapter, first of all we are going to discuss about the point density. Each body has a certain mass and a definite volume. We know that every body has a certain mass, a particular mass and a definite volume. The volume occupied by a body increases if its mass is increased. If the mass is increased, the volume occupied by a body also will be increased. Okay. So further it is found that equal masses of different substances have different volumes. And another point is equal masses of different substances have a different volumes. If particular substances masses are different and its volume can be different. For example, the volume of a cotton is much larger than the volume of an equal mass of lead. Okay, the volume of cotton is much larger than the volume of an equal mass of lead. This is because the particles of lead are closely packed while those of cotton are very loosely packed. If you consider lead and cotton, the molecular arrangement, we have learned about this molecular arrangement in first chapter. Consider these both substances, cotton and lead. The molecules in a lead arranged very closely and cotton little far arranged. That's why the volume of cotton is much larger than the volume of an equal mass of lead. In other words, lead is denser than cotton. In other words, we can say that lead is denser than cotton. Okay students? And another point is equal volumes of different substances have different masses. Equal volumes of different substances have different masses. For example, the mass of iron is much more than the mass of an equal volume of wood. Here we are going to consider two substances, one is wood, another one iron. Clear? The mass of iron is much more than the mass of an equal volume of wood. Why? This is because the particles of iron are more closely packed than those of the wood. It depends on the molecular arrangement of the substances, particular substances. Here we are discussing about iron or wood. Which one has more tightly arranged molecules? Definitely iron. Okay, the particles of iron are more closely packed than those of the wood. In other words, iron is denser than wood. Thus, to explain that equal volumes of different substances have different masses or equal masses of different substances have different volumes, we use a term called our main point, that is density. Okay, the word density we are going to use for this particular concept. It is defined as follows. The density of a substance is its mass per unit volume. Please mark it. The density of a substance is its mass per unit volume. Therefore, density of a substance is equal to mass of a substance divided by volume of the substance. Mass upon volume. Density of a substance is equal to mass of a substance divided by volume of the substance. The density of a substance is represented by the symbol D. Okay, the density of a substance is represented by the symbol D. If mass of a substance is m and its volume is V, then we can write it as D is equal to m upon V. D is equal to m upon V, that is equal to mass upon volume. Now we are going to discuss about the point units of density. Unit of density is equal to unit of mass divided by unit of volume. Unit of mass divided by unit of volume. So here we can discuss, in the SI system the unit of mass is kilogram. The SI system, the unit of mass is kilogram and unit of volume is meter cube. Okay, in SI system the unit of mass is kilogram and unit of volume is m cube. So SI unit of density is kilogram per meter cube. The SI unit of density is kilogram per meter cube or kilogram per cubic meter. In the CGS system, unit of mass is gram. The CGS system unit of mass is gram and unit of volume is centimeter cube. So in CGS system, CGS unit of density is gram per centimeter cube. Gram per centimeter cube or gram per cubic centimeter in CGS unit. In SI unit it is kilogram per meter cube. Okay, it is kilogram per meter cube. Okay students, now we are going to discuss about the relationship between SI and CGS unit. We know that 1 kilogram per meter cube is equal to 1 kilogram upon 1 meter cube. We know that 1 kilogram is equal to 1000 gram. 1 meter cube is equal to 100 centimeter cube because 1 meter is equal to 100 centimeter. Okay, that's why we can write here 1 kilogram upon 1 meter cube is equal to 1000 gram divided by 100 centimeter cube. Clear? So that is equal to 1 upon 1000 gram per centimeter cube. 1 upon 1000 gram per centimeter cube. So we can summarize the value like this: 1 kilogram per meter cube is equal to 10 raised to 3 gram per centimeter cube. So we can write it as 1 kilogram meter cube is equal to 10 raised to minus 3 gram per centimeter cube. 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. Okay, here we can discuss one example. Some examples we can discuss here. Example 1. The mass of an iron cube of volume 10 centimeter cube. Okay, please listen here. The mass of an iron cube, that is 10 centimeter cube, clear, of volume, that is 10 centimeter cube, and is equal to 78 gram. Clear? So density, the mass, that is m is equal to 78 and V is equal to 10 centimeter cube, means mass is equal to 78 gram and volume is equal to 10 centimeter cube. So density of iron is equal to 78 upon 10 centimeter cube, that is equal to 7.8 gram per centimeter cube. Okay students, now the mass of, second example, the mass of 1 centimeter cube of water is 1 gram. Okay, just listen here. The mass of 1 centimeter cube of water is 1 gram. Hence, density of water is 1 gram upon 1 centimeter cube. That is equal to 1 gram per centimeter cube. Okay, students. Now, third example. Our third example is a piece of copper. A piece of copper of mass 8.9 kilogram. Please mark it. A piece of copper of mass 8.9 kilogram has volume of 0.001 meter cube. Then the density of copper is 8.9 kilogram upon 0.001 meter cube. That is equal to, by calculating this one, we will get 8,900 kilogram per meter cube. Okay students. Now here is an interesting fact. Do you know? The density of a substance does not change with any change in its shape or size. Okay, the density of a substance does not change with any change in its shape or size. Density won't change, density will not change with any change in its shape or size. Almost all substances expand on heating and contract on cooling. Okay, almost all the substances expand on heating and contract on cooling, but their mass does not change. In expansion or contraction, the mass won't be changed. So the density of a substance decreases with the increase in temperature. The density of a substance that decreases with the increase in temperature and increases with the decrease in temperature. These 2 points, decreases with the increase in temperature. Exception is there for water. In case of water which contracts on heating from 0 degrees Celsius to 4 degrees Celsius. Water contracts on heating 0 degrees Celsius to 4 degrees Celsius and expands on heating above 4 degrees Celsius. Okay, expands on heating above 4 degrees Celsius. So the density of water increases from 0 degrees Celsius to 4 degrees Celsius and then decreases above 4 degrees Celsius. That is, the density of water is maximum. The density of water that is maximum at 4 degrees Celsius, which is equal to 1000 kilogram per meter cube. Mark the point. The density of water is maximum at 4 degrees Celsius, which is equal to 1000 kilogram per meter cube. Okay students, please mark it. Now we are going to discuss about the point determination of density of a regular solid. Okay students, to determine the density of a regular solid, first measure the mass. Find out the value of m, mass, by using a beam balance. 7th class we have discussed this point. Okay, first of all, to find out the density of a regular solid, we have to find out the mass m by using the beam balance. Now find the oleum V of the given regular solid. The oleum V. Now find out the V of the given solid using the formula volume of a cube is equal to one side cube or side cube. Or if it is a cuboid, use the formula volume of a cuboid is equal to length into breadth into height. Clear? Length into breadth into height. The volume of a sphere is equal to 4 upon 3 pi r cube. If it is a sphere, how to find out the volume? By using the formula 4 upon 3 pi r cube, means radius cube. If it is a cylinder, which one we have to use? Volume of a cylinder is equal to pi r square h. Pi radius square into height. Pi radius square into height. Pi is a constant value, that is 3.14. So many equations we have discussed now to find out the volume. First of all, to find out the density, we need a M, and next we need a V. M can be found out by beam balance, already we have discussed. V of the regular solid can be found out by the equations which we have discussed just now. The side of a cube of or length, breadth and height of a cuboid, or radius of a sphere, or radius and height of a cylinder can be measured with the use of a meter ruler. This all length, breadth, height, radius and all we can find out by using the meter ruler. Then next step, by knowing mass and volume V, mass M and volume V, calculate density D of the substance of the given regular body by using the formula D is equal to M upon V. For example, one example we can consider here. If mass of a cube of iron is 210 gram, means M is equal to 210 gram. One side of a cube is equal to 3 centimeter. Volume of cube is equal to one side cube, you know that, side cube, then 3 cube, that is equal to 27 centimeter cube. Now we can find out the density by using the formula density D is equal to M upon V. We know the value mass is equal to 210, then volume now, that is 27 centimeter cube. By doing the calculation, 210 upon 27 will get the answer 7.78 gram per centimeter cube. Okay, now we are going to discuss the topic vessels for measuring volume. Vessels for measuring volume. Okay, it's a time to wind up our class today or session today. So wait for next video to hear about vessel for measuring volume. Till then, goodbye and have a nice day.